So here we are talking about, well, yeah, it's a good screen. Heavy computation in Node.js with Rust. So I know we are in a Node conference. Just small reminder, I love Node.js. I do a lot of work with Node.js, but I think there is only 2 lines of Node.js in this talk. So if you like Rust, it's good. If you don't like Rust, sorry, fine. But you will love Rust after that. Okay, so another title for this conference and this talk could have been using Node.js, Node API with a hype language for fun and profit. I'm not sure I would have been selected to give this talk with a name like that, but at least you are able to see it. So why fun and profit? Because just basically, we are all writing Node.js API. We are using JavaScript maybe to write front-end application, and that's great. But JavaScript is not a silver bullet which allows you to do everything in the world. You are able to work with IoT, you are able to work with API, compute, to write front-end application, to write pretty much everything, to send, to have some control screen on rocket going to space and stuff like that, which is really great, but it's not the best technology for everything. I'm Jean Burellier. I will be speaking for the next 20-ish minutes about that, and you can find me pretty much everywhere on internet with the name Cheplu. Except Twitter, I'm still trying to be able to have my normal nickname, but yes. I'm also working, since the past year I was working for Allianz, so insurance company, and as a principal engineer, now I'm taking more, let's say a year off to work with academics and to help new people. I'm really into sharing and mentoring people, so I do spend a lot of time with new students coming into the field in IT and building stuff. Also, I do love to travel, and I'm French, as you can hear. Yeah, so, yeah, food. And I do have one question. Is there any other French people in the room? Yeah, 1, 2. No, you are not French. So what? Yeah, great. I'm not alone. Okay, so what's the agenda for today? We'll be talking a bit about native code in Node.js, but also the NAPI or Node API revolution or evolution, and let's try to do some demo on Rust with Node Bindgen. First question, has anyone ever used Node API or NAN or native module, native add-on with Node.js? Oh, still a few people, that's great. Great, okay. So for everyone else, add-ons or native module are just basically dynamically linked shared object written in C++. You will use your basic require function in JavaScript, in Node.js to load every add-on, like every library you are used to load this way. And which is really great is that the add-on part provides an interface between JavaScript and the C and C++ libraries. I'm speaking about C and C++, but it's also mainly every language which can work with that, so with FFI or pretty much everything, and Rust is a perfect candidate for that. For also, one key point is, like you can expect, in JavaScript, we don't really have a lot of type. It's just basically everything is an object. But in C and C++, you can use pretty much a lot of stuff which are not directly compatible to JavaScript and vice versa. So you need to find a way to communicate between both. We do have a bridge, and this bridge is doing mainly the translation between the two worlds, the two technologies, the two languages, to exchange information and be able to communicate together. Which, as you can expect, it's not simple, it's not straightforward, and you can have, let's say, some issue. I will come back to that a bit later, but you can have some issue. And writing native extension requires knowledge also because you need to interface yourself or your code with the C++ part. So you also need to learn about libuv, v8, Node.js internals. So quite a lot of stuff which are not really teach or you use basically on your day-to-day life. And the other part is also if you need to require or to work with some low-level stuff like OpenSSL, or for example, you will need to try to find a way to access it or to find some information about that, which can be quite hard because it's also a bit separated. Yeah, some code, like I told you, not a lot of JavaScript, so definitely not JavaScript code here. It's basically just a module to say hello world using this native add-on. So great code, it's perfect. You can see you do have some V8 namespace, which depend and which has been loaded. That's great. I'm not really a C++ guy. It's been a long time since I haven't just even read some C++. I can understand it, but mainly it's quite hard, and if you want to build a lot of big functions or stuff like that, it will be really hard to, if you are not an expert in this technology, in this language, it will be hard for you. But it works, and you are able to display hello world. That's great. And with a small target, with an add-on, you are also able to just provide and build everything else around that, which is great, but, because right, always a but, it's really simple, a simple way, and you will still have to work with V8 and mainly low-level stuff if you want to build something which is really powerful. And when it's done and when you build it, so it will be generated in your build or release, something really depend. You just need to load it with a require, and it works. So that's great. This part is not really, it's really easy to use a library. For example, and I will come back to that later, you were maybe using Node.js in the past. Node.js was native add-on at one time. You also do have some driver like SQLite 3, I think, if I remember right. So yeah, a lot of stuff. And like I said, problems. Problems, 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 every time. Node.js, which is great, is constantly evolving. We bring new feature, new evolution, but you also have V8 implementation, which change every, let's say, too often. And so the interface between V8 and maybe your native add-on will break because some changes happen or people just wanted to update something. So it will just basically break. So it means that every time a new Node.js version, V8 version will be released, you will have issue with your code. You will need to compile everything again, expect that it will work. And if not, you will have to do some changes. That's why on the Node.js part, we did a module, let's say, called NAN, Native Abstraction for Node.js, which at least this time we choose a really good name. It's definitely not a number, so that's great, at least. And mainly, so it's here for since 2015, something like that, so 7 years old. And it provides really a layer of abstraction on top of the Node.js API, which allow you to not handle V8 changes or low-level changes, and you only work with this layer of abstraction, which tend to change a lot less as we try to make it that it doesn't change on every time. And it's basically just a common interface, like if you are a Java developer in the past or something like that, DAO stuff, and you just update what's behind that, and it's hidden for your application most of the time. A small example, if we check the main difference between the previous example and this one, it's really the V8 part, which is not just NaN. You do have some other stuff which change, but basically it's still low-level C, C++. For some expert in this technology, you will be able to understand everything. And yeah, so that's pretty good. But we still have some issue, because it's not perfect. The NaN part is not perfect. It's try to keep everything consistent and to allow you to not update everything when it changes, but it's not perfect. So the Node.js people and maintainer and contributor worked on something else called Node API. So the previous name was NAPI, so you will find a lot of documentation called NAPI, and most of the modules which are done by the community are also NAPI or something like that, but it changed like 1 or 2 years ago, something like that, to Node API right now, which, to be honest, it's a really bad name, as when you search online on Google or something like that, just look for Node API, it will be hard to find a good documentation or stuff like that. And one of the main points of this Node API is really we provide a stable ABI, so application binary interface, which define and just export C type and function. This way, it's really some kind of middleware between the low-level stuff and your JavaScript stuff. And we try to just have a full abstraction of the JavaScript engine and to allow you to build stuff on top of that. And we guarantee you that we won't break anything. I don't know if some people which were working with an API had some issue. I would love to hear for you if you have some, but yeah. And this work started 6 years ago. Okay, so what do we want with Node API? First, a full compatibility across different major versions of Node.js. So you don't need to upgrade or to do a lot of, basically you don't have to do any work at all when you update from Node 12 to 14 to 16 to 18 to 19, 20, stuff like that. So it should be clean, no change, no update. You don't need to recompile any module at all. Also, it allows you to work with other JavaScript engine than V8, so I'm thinking about Chakra Core and other stuff. It can also help you to work with that. And finally, it's just an API, just a C API, which allows you to implement native add-ons with language other than C and C++, hence Rust. Or some people are also working with Go. I think I saw a Go abstraction module in the past month that someone was doing that for fun. So that's great. But pretty much you can implement it, and if you want to write some COBOL and API implementation, feel free to work on that. Could be great for banks, insurance, for example. So the main premise behind that is that if it's done right, when you write this kind of module, it's completely hidden for your end user on how, if the module is a JavaScript module or if it's just a C, C++ or Rust module. They will just see it as a basic Node.js module and think it's JavaScript until they go check for it. So, in my title, I spoke and I use a Rust keyword. Why Rust? Because I do like to write some Rust. I also really bad in C, C++ nowadays. So basically, let's focus a little bit on Rust. You have three main, let's say, technology or tool written by the community which allow you to easily bind everything with an API and Rust. You have NAPI, RS, NodeBindGen, and Neon, which are the three most used, let's say, technology around that. I think you do have also some other language or other library available on GitHub, but I don't know about the other one. Let's try. So, as I said, I won't write any JavaScript code today. Because, whoop, if I don't lost my screen. Yep. Okay, so, let's. Okay, great. So I don't have anything, any project at all, anything. Let's create. So let's build a new Rust project. Great. I do have a project. Let's open it. And let's zoom for you. Okay. It's maybe a bit too much. So if some people just already know how to use Rust and write some Rust, you basically do have your cargo.toml, which is basically your package.json, and an src folder with a main rs file with a function, a main function saying hello world. Great, perfect. I think it's good for everyone. In my case, now, I do want to use and to be able to provide, to build something in Rust to be used as a library, let's say a library or a module to be used by my Node.js later on. So how can I do that? Like I said, I will be using NodeBindGen. It's not the only one technology, but let's use this one because it's the one I'm using most of the time. So let's add it. Let's add NodeBindGen. Well, really bad writing it. Or I can copy paste it. It will be a bit easier. Yep. Let's copy paste the 3 lines that are needed. Okay. So basically, what's these three lines are for? First, I require a dependency, Node.js, with a version 5. That's great. Also, for the build dependency, which means when I will build my project, it will use bindgen to do some changes and to do some link information, which will add some, let's say, feature and being able to build a library and the library being used by JavaScript after that. And the last part is that I just define it will be a library and I will be a C library or C linked library at least. Okay. First step, okay, my package or cargo tunnel is good. I have every information which is needed to build my project and to do everything. Next step, what do I need? I need to say to my project that I do need to use some custom configuration for the build part. I think, yep, it needs to be outside. So I need to define a build RS file which will give some information to my Rust project when I will try to compile it and build it. What should I do? Basically, just a main function saying that I will use Node.js, and for the build process, I will run an automatic configure, which is a base default configuration information by the project. That's all for this one. And almost the last part is, let's change. I'm building a library, not running it, so I need to redefine. It's not a main file, but it will be a lib, so lib.rs. Okay, great. How? Let's say this part is really the setup of everything on your Rust project, and you are now able to start and write some stuff. But one missing stuff is really how to say to my build and to my build and Node.js how to use it, and which function does it need to link to your C++ interface after that. So I will just basically use here on my main function. So I want to use Node.js derive Node.js, great, don't forget that, and no space. It would crash. Okay, great. And for my function, let's add that I want to link it and use it with Node.js. Okay, great. I think everything's done. If I don't have a demo effect, it should work. Where is my terminal? Here. So now, if I want to just build it with Node.js, you do have a full CLI, ng.cli, and you can just write .build. It will take a few seconds to compile and pretty much do everything, which should almost be over. On massive scale project, it will obviously take more time than just that. But basically, it's doing pretty much everything. Almost the time maybe to take a sip of coffee or tea, but that's all. And no error, which is great. No typo, perfect. And now if I want to use it, if I check just on my, here, on my project, it just created a target folder and a this folder with some index.node file because it's what will be used by the Node.js library the Node.js code to use and to run the library. Okay, great. How do I use that? Let's open Node. Basically, okay, let's first load it. As I said before, it's basically like just a basic Node.js or JavaScript module, so just require the name of the module, the dist. Yep. Okay. And if I want to use it, just use it as a basic module that you will be requiring. So, okay, add the function. I only have one function, which is the main function, and it works. I do have my hello world. Not really a big example, but basically, if you want to do pretty much everything, it's just that way, the configuration, then you just have to write Rust code doing what you want. Maybe processing images, processing big data set or anything, or pretty much everything. So quite easy and quite fast to do so. Setup is like, what, 5 minutes, something like that, which is pretty good. Also, you do have a lot of performance improvement. I will show that just at the end. But mainly why you want to use Node module, Node native module, add-ons, and API. It's because sometimes you need a better way to compute heavy images, maybe heavy file, because you have to handle megabyte, gigabyte of data, and you want to do it quickly because you want to not spend days doing some compute. So it's really useful if you want to do image and video processing, maybe compression stuff, also everything linked to your CPU heavy task. If you want also to work with math, because as we know, JavaScript is not the best when you want to work with precision number or some math complex operation. So it can be great also to use that for this part. But for me, mainly the main part now is really to just reuse existing code base on your company. So maybe you do have some legacy application which are using C, mainly C, C++. I don't think you have legacy application in Rust yet. Maybe one day. But now it's mainly C and C++. And it allows you to have a really fast integration because this way you are just able to take your old C, C++ library, bring it to your Node.js project, and with Node API to be able to deploy it on every cloud provider, just on a Docker system, Docker image, and it will work out of the box. This way, no need to rewrite your 20-year-old C++ application for your insurance or bank, and no one knows how it works or anything else. So that's pretty good. This way, you can really expose your core functionality, change, and maybe also kill your old data center / mainframe application, which costs you a lot and no one really want to maintain. So yeah, it's pretty good. Also, another part is maybe you want to use in JavaScript, in Node.js, some features which are not available by the ecosystem. I'm thinking, for example, maybe TensorFlow. So I know TensorFlow has some JavaScript API. But if you want a core feature, maybe you can use that, or maybe image processing if you want to use FFmpeg. If you want also to use custom driver like GPU, maybe you want to do some, I don't know, heavy compute on your NVIDIA or graphic card or stuff like that. Currently, it's not really possible, even if NVIDIA released a few months back some driver to access directly to your data, to your NVIDIA, or at least NVIDIA graphic card. It's not the best way, so maybe you have a solution which works with that. Okay. Sometimes also low-level API, and one thing which is great, it's working also on desktop application. Great. I told you I did have some example like Node SAS, Node Canvas, Node SQLite 3. V8 Profiler, I think, is using that also. Not entirely sure now. Yeah, and we do have a lot of examples on a Node.js project. You can look for that. We will try to also add a lot more example, write article. I think we discussed about that in the last working group meeting. So it's something which is growing, and it would be great if some more people want to be involved. Don't hesitate, just join us doing that. Small tips and feedback about using that. Full disclaimer, I do have just some basic example in production in my old company, not a full scale because of just requirement. But first, Bridge is really costly. You cannot really focus on exchanging a lot of information really fast. So try to just send a bunch of information, handle everything else, and just forward the result at the end. If not, you will lose a lot of time between JavaScript and Rust or pretty much everything every time you cross the bridge. Second one, it's really useful for processing heavy data. Most of the time, I'm around 4x to 5x improvement, so which is pretty good. Also, you do not need to rewrite everything as a native module. Please don't say, let's ditch everything in Node.js, just keep Node.js as a base and rewrite everything in Rust. Could be great, but I'm not sure your company will agree with that. Yeah. But you can try to implement some old stuff or core stuff or part of functionality that you do require more heavy compute part. Also, Rust is really cool, so I love Rust. And I think someone also is talking about WebAssembly tomorrow, so WebAssembly is really good. It's working on the browser and pretty much everywhere, so it's also a good stuff. And just before that, I want just to give you a small example of a basic project. It's really a simple one without any optimization. Up. Okay, so as we know, one of the key solution that is, let's say, heavy compute is just a basic Fibonacci function. So this one is just a basic Fibonacci in Node.js. I think it's going to the 40th item, so it takes 6 turns, which is great, but could be way better. The same function being written in Rust is way faster, like 1.5, so on, so 4 times faster. So that's why it's really nice to use it for some compute intensive. If you are doing image processing, stuff like that, it's great. And that's all for me. So yeah, you can find me if you're interested to maybe discuss about it, join and talk to me. I will be in the venue for the next 2 days, so do not hesitate about that. Thank you.